Today's topic is about the regulation of glycogenolysis by hormones. Let's start with glucagon and epinephrine on liver beta receptors. First of all, for those who don't know what is glycogenolysis, it's a pathway that's responsible for breaking down sugar stores present in the form of glycogen inside the liver and release them as a free glucose molecules. This pathway is activated when there is a decrease in blood sugar levels. Amazing. Now let's talk about how the glucagon activate all this pathway. First, this receptor, the beta receptors, are coupled with three subunits, alpha, beta, and delta, where alpha subunit is coupled with a GDP molecule, forming a G protein. When there is alpha, beta, and delta with a GDP, this is the inactive form of beta receptors. Once a glucagon is released for whatever reason and binds on its receptor present on the surface of hepatocyte, the beta receptors, a change in the subunits will occur, forming alpha, beta, and gamma. This change or this binding of a glucagon will activate the receptor when the GDP is converted on a GTP. Once this GTP molecule is formed, it will dissociate the alpha from the two subunits gamma and beta, allowing the activation of adenyl cyclase. Thus, when alpha and GTP are dissociated, this GTP molecule will allow the activation of adenyl cyclase. This enzyme that is present in the membrane of hepatocytes will allow the conversion of an ATP molecule into a cyclic AMP molecule. So AMP, which means adenomonophosphate, so one phosphate group. However, ATP adenotriphosphate, where this conversion will release two inorganic phosphate group alone and a cyclic AMP. This cyclic AMP is also named a second messenger. Keep in mind that when GTP is obtained and activate the adenyl cyclase, it will release and form the GDP molecule. So we'll use one phosphate group for the activation of adenyl cyclase, and the remaining two phosphate group will be coupled by a GDP molecule. This GDP molecule will return and bind to the delta, beta, and alpha, forming the inactive form of beta receptors until another glucagon come and activate it again. Alright, once this cyclic AMP is produced, it will be used for activating the protein kinase A. It is an enzyme that's made up of many subunits, catalytic subunits and the regulatory subunits. When the R subunit, the regulatory subunits, are bound to the catalytic subunits, the Phe subunits, this protein kinase will be inactive. But once cyclic AMP is produced, it will work on activating the protein kinase A by binding to R subunit, dissociating them from the C subunit, allowing the release of free C subunits, the catalytic part of protein kinase A, forming the active form of protein kinase A. So this protein kinase A activation is really important because it will intervene in the conversion of glycogen, the sugar stores, into a free glucose inside the bloodstream through a variety of pathways that we will talk about in the upcoming slides. Now the protein kinase A is activated. Amazing. First of all, in order to activate the glycogenolysis, we should inactivate the glycogenesis. So, glycogenolysis is the pathway that convert the glycogen, the sugar stores, into free glucose molecules that will enter the bloodstream. However, the glycogenesis is the opposite, which means it takes the free glucose present inside the blood and stores them inside the liver in the form of glycogen. Thus, for the activation of glycogenolysis, which means the release of free glucose molecule, we should shut down the pathway that stores this free glucose inside the blood. For that reason, this protein kinase A should inactivate glycogen synthase. Okay, glycogen synthase is the main enzyme needed for the activation of glycogenesis, and it is present in its active form when it is not phosphorylated. This protein kinase, the active one, will add a phosphate group on this glycogen synthase, inactivating it. So once the glycogen synthase is phosphorylated, it will be inactive, and thus glycogenesis will be inactive also. After ensuring that glycogenesis is inactive, now we should activate the glycogenolysis. How this going to be done? It's all about the activation of a glycogen phosphorylase, main regulatory enzyme of glycogenolysis, which will be mediated by protein kinase A. This protein kinase, the active form, will phosphorylate the phosphorylase kinase, the inactive form, and converting it into the active form once the phosphatic group is added. So once the phosphorylase kinase, the inactive form, is phosphorylated, which means a phosphatic group is added on it, it will be activated. Once this phosphorylase kinase is phosphorylated, which means activated, it will activate the glycogen phosphorylase B by phosphorylating it, forming glycogen phosphorylase A, the active form. The formation of a glycogen phosphorylase A, the active form, will activate the glycogenolysis by reducing glycogen into the free glucose, of course, by a variety of steps. This glucose produced will be released into the blood. So, if you want to sum up the activation of glycogenolysis, first, we should ensure that glycogenesis is inactivated by adding a phosphatic group on a glycogen synthase, inactivating it, and by phosphorylating the glycogen phosphorylase also for activating the glycogenolysis, which means the activation of glycogenolysis depends solely on the phosphorylations. But the problem that there is an enzyme named phosphoprotein phosphatase that at any time could remove all the phosphorylations occurred, reversing the end result, the activation of glycogenolysis. For that reason, the protein kinase will work on inactivating this phosphatase by phosphorylating the inhibitor 1. Inhibitor 1 is an enzyme that will exert a negative effect on the phosphoprotein phosphatase by inactivating it. So inhibitor 1, when it is not phosphorylated, which means without a phosphatic group, is inactive. Once the phosphatic group added on it, it will be active, hence affecting the phosphoprotein phosphatase by inactivating it, and ensure that there will be no removal of the phosphorylations, which means keep on activating the glycogen phosphorylase and inactivating the glycogen synthase. And by this, we will end the topic. Hope I make it clear for you. Don't forget to subscribe, and I will leave links in the description for other YouTube videos. Thanks a lot.